Just spin it and take the second one.
Okay, so
Where did you? What was running?
I just got in that situation.
Oh, you were in that situation.
Yeah.
Which one did you do? A or B?
After. What was the situation? Not concerning to you.
okay.
Not a problem you never have.
Wow. Moving on from that out of pocket slightly comment. Couple things before we talk about average value, which is our main topic for today. To find the average value of a function, super easy. There's a formula for it, which involves the definite integral. So it makes life easy. This is something that we talked about last week, and I was like, I still feel like I'm wrong, and so I did some research on it. And I said to you that if it's continuous, so we said continuity, I spelled that right. Continuity makes something integrable, because we talked about that word. Remember integrability? That's true. There are some situations though where you can have a discontinuity and it's still able to be integrated. Okay, so I just want to give you those. So this is true always. If it's continuous, you can do its integral. But a jump discontinuity, which is also called a step, right? Jump discontinuity or a removable discontinuity, which means a what? Yep. Hang on. You can still do the integral. Just a second. Okay. So we have, I said, if it's continuous, you can do the integral. If you have a jump discontinuity or a removable discontinuity, you can still do the integral. Generally speaking, those are ones you would do with area. Okay, so let me give you an example. So let's say you had something like this, and then it went to this, right? And you're doing the integral of that area. You would split it into two triangles, and you would do this side, and you would do this side. Okay, so that is a thing. You still can do the integral if there's a jump discontinuity or there is a hole there. I do not know if that is true for the fundamental theorem. I feel like it's not. But
what happens if we differentiate something that was never like a derivative to start with? Like when we take derivatives of things, they get simpler and simpler. Does it get more complex somehow?
I don't know. Yes, you can go in either direction, right?
The C value, would that be the issue?
Yes, you'd have to have the numbers to get your C values, right?
If you had the numbers from C value, it would mean that it was already differentiated, and it was that you had it.
That you had it, and it was something strictly. Not necessarily true, Mason. So you can have so like if I said to you you can continuously integrate sine x, right? Because it just continues, it just goes back and forth. So it doesn't have to be, I guess. There you go. Okay, so this is what I just wanted to tell you because I did some research on that and I wanted you to know what's true. I will look about the fundamental theorem and let you know about that, but my gut says no because, well, that's not true because you could do the integral of one side and the integral of the other side. Okay, and then add them together.
But
do the fundamental theorem.
Wouldn't it have to be a fraction for a whole? Like your equation?
Nope.
It doesn't have to be?
Okay, so I'm not saying that we could necessarily do it at this point in time, but it's doable. Okay. Does that get what I'm saying?
Yeah.
Okay, so let's talk about average value of a function. There's an equation for average value of a function. So the average value of a function basically says do the integral from a to b of f of x dx. There's a regular integral, and then the average value would be out front. You're going to divide by 1 over b minus a. So this is not what, Avery, you want to maybe not sleep through this one. This is not average. Like when we think average, I think sometimes our brains go to like algebra average, and we add them all up and we divide by how many there are. This average value is different. It's, well, let me give you a concrete example. Okay, so let's say you went on a trip and you had an equation for your velocity. I'm going to make you a nice equation. So this is whatever. Not actually accurate for what you would do. Let's say you started out going 60 miles an hour and you just progressively were like, I really would like to go a little faster. And so you started increasing your speed about 5 miles an hour, right? So every hour you increase 5 miles an hour. Okay, so this is your velocity. Let's find your average velocity. For a, that's for a, 2 words, 2.75 hour trip. Okay. So I want to be a little bit more specific a second about average value. This is the average value of f of x. And you're going to be like, well, why does that matter? So it matters that this function matches this, and it will make sense when I ask you this. When we find the average velocity, then I better be having an equation here that has velocity. This is my velocity equation. Okay, sometimes people are like, average velocity, I gotta do the derivative of that. Don't do the derivative of that. Okay, now, if our trip is taking 2.75 hours, we started at 0 and we end at 2.75. Now, listen to me a hot second. If I just do this much of it, what will that give me? How many miles I went, indeed. Which means it's my what? Distance. If I then do 1 divided by 2.75 minus 0, that is distance divided by time, which is velocity. Okay, so you can see that it works. So let's do that. It's not a beautiful number, but because I picked 2.75, but that's okay. So let's do the fundamental theorem on this part. This is why we are happy we have calculators, because nobody wants to square 2.75. I feel like it should be longer than that, but whatever. Okay. How many miles?
183.91.
How about 906? Because we go 3 decimals, right? And so then,
They didn't give me. How do I make it?
great. Multiply by 1 over 2.75, which is the same as dividing. $66.875. Yep, it is settings.
I know I'm looking for settings.
It's mode. Sorry.
You just want to put it. You
Did you put it into your table? Is that why?
Okay, so yeah, did you put it into your table?
Over it to see what it actually is.
Do you get what Mason's saying?
Yeah.
Okay, so I'll show the rest of you guys that too. If you put it into your calculator, 60x minus 2.5 x squared. and you're going to go to your table, 2.75 and 0. So Garrett's right. It does not show you all those decimals. So if you want to see it, you just put your cursor over it, and it gives you the whole mess down in the bottom. Okay. That's not the right number though. Is that what you just said?
Yeah.
Yeah, I don't type in.
Me neither. 60x minus 2.5 plus. Mm-hmm.
So you type in.
How about that?
One into your calculator.
There you go. 183.906. Did I type in the 0? I did, but I don't know. I shouldn't have. Okay. And then divide by 2.75 or multiply by 1 over 2.75. Okay. This average value happens a lot on the AP test. And where I've seen it is that they give you actually a table. They have you do a Riemann sum or a trapezoid rule, and they ask you about the average value. So then you got to be like, oh, here's the integral, which I got from my Riemann sum, and then divided by whatever distance you had there from A to B. So this would be miles per hour, would be our average speed.
If you have the numbers from, why would you do a not exact estimate?
Okay, so let's say we have I was thinking about this. Let's say we have this. We did this a while back. So let's say it's X is time, and this is temperature of the oven. If you're making cookies, because that's always good to make cookies. And so at 1 minute, it's 351. 2 minutes is 349. 3 minutes is 340. Sorry, it's not a decimal, 347. 4 minutes is 352. And then 5 minutes is 350 again. Okay, so this is the temperature of your oven at selected times during your cookie baking process. This time is in minutes and temperature is in degrees Fahrenheit. So I would like you, 1, 2, 3, 4, to estimate the definite integral with a R sub 4. 1, 2, 3, 4. R sub 4, please.
Does it matter if we use squares or trapezoids?
If it's R, it's rectangles.
Okay.
T would be trapezoids.
Okay.
I thought you had to say if it was left or right. Or do you not have to?
It is, it's R.
R.
Oh, yes, I remember.
So R, not rectangle, R for right.
Yes.
Yep. So RLM for rectangles.
Use the number as a right. So there's a 1 and 2, and then there's 351 and 349. Use 349.
Triangles or trapezoids?
Or trapezoids, sorry.
No, because a trapezoid, like if you did a trapezoid, you're using both of those bases anyway, right? Because you're adding together. It's all right. It's Monday.
I was thinking of the graph.
Right.
Or you can do the shortcut and add them all together and multiply. Because it's all the same. And you're also multiplying by 1, so it's.
Right. So it's 1. You just skip that step. Anyway, what is R sub 4?
1,398.
Yeah, 1398. Now, let me ask you this question. What would be the units on that?
Degrees Fahrenheit? No.
Degrees per minute.
Mm-mm.
Minutes per degree.
Mm-mm.
Minutes.
No,
I think it's degrees Fahrenheit.
it's degree Fahrenheit minutes. Okay, because listen, which doesn't make any sense. So we'll throw that out there because it's the Y units times the X units, which would be degree Fahrenheit minutes. That doesn't make any sense. Don't worry about it. Okay, because why I just want you to know it doesn't make any sense. Now, I want you to find the average value of this function on the interval 1 to 5.
So they would give you the numbers after
Just,
just
but
for
we
this.
still have to write degrees Fahrenheit.
No. Okay, average, I want you to find the average value from 1 to 5. Use this as your estimate for the definite integral, and then tell me what that number means, because that one will have meaning. Okay, so find the average value from 1 to 5 using R sub 4 as your estimate of the definite integral.
So do we do that?
Is that what goes in the function?
No. Okay, so you're doing from 1 to 5, 1 over 5 minus 1 of temperature. So I'm just going to call him T of X. Okay, this is what you have an estimate for already, right? You have that estimate. What's that estimate?
13,
Yeah,
so we multiply.
yeah. Okay, so it's going to be 1398 divided by what? 4. What do you get?
349.5.
349.5. What's that going to be? Degrees Fahrenheit. Now, what does that tell you?
That's the average temperature.
That's the average temperature of my oven. Okay,
During the interval 1 to 5.
from on the minutes 1 to 5. Now, I've seen them like this where they ask you, they take you to those 2 steps and then they ask you, what is that? Like they want you to be like, ooh, when I divided by that, that's the average value. Or they want you to recognize the process as being like, ooh, I divided by 1 over b minus a, that makes it the average value of the function. So that's the average temperature of the oven. Okay, so anyway, let's do actually one that does not have context, because this would be like most of your homework.
Why are there 2 like average equations? Like, shouldn't the average be the same? Because I got different answers because I tried the other one too. Because
What other one?
like to add them all up and divide by it.
Yeah, because that's not the same. That's just
I'm
the
wondering why it's different.
I got what you're saying. Just a second. No, it would be the same in this case. Oh, because you took
I added them all up. It's at
divide by
right
5.
hand limit,
Divide by 5. What'd you get?
349.8. So it's off by 0.3.
Yes.
Would it
2 different ways of finding average.
Wouldn't it be because
So the difference is that this is the average value of the function, whereas that is just an average, and that seems like it's a really small distinction, which it is. But the reason that we want that is because, or we use the formula because we won't always have a table. That's why we got to be able to find the average value of a function itself. Just a second. So let's see, x squared plus 5x. No, those are terrible numbers. Let's go 3x squared plus 4x minus 2. Let's find the average value on the interval 0 to 6. Okay, now I'll answer questions.
It was just.
Okay,
I was just gonna
Joe,
say,
then Mason.
it was just like the difference between using like Riemann's and like a trapezoid, right?
Kind of.
It just the difference falls in what numbers you use and how you use them.
A little bit, but also like what I was saying to Garrett is it would make a whole ton of sense to be like, if I wanted the average value of the oven, I would add up those 5 numbers and divide by 5. Average value of a function is slightly different, and we have to be able to have a formula that works for a function given. I would guess if we used the trapezoid rule, it'd probably be closer to Garrett's estimate.
So on that last one, it was Fahrenheit times minutes. Will it always work out where it's literally just our 2 axis units multiplied?
For a definite integral, yes. Always. Because it's x times y, right? Because it's the definition is x times y is y varies, and so always. Touch the bottom in.
So we can do all the
Put the
math
bottom in.
stuff and then just let the units after.
Absolutely.
About it.
Absolutely.
Yeah, I was confused when she told me that earlier.
Antiderivative this.
Can we antiderivative this? Because it's not, it's just mathematics.
Okay, so listen, this is what I was saying to you. When I ask you for the average value of a function, you have to write yourself a formula. You have to go, average value. The formula is the integral of f, 3x squared plus 4x minus 2, on the interval 0 to 6. Like that. So let me go back to my note a second. Like when I said to you this, if I say the average value of f of x, you have to write the integral. That's what I was talking about there.
It's not necessarily a derivative.
Correct.
Okay.
It's not necessarily a derivative. It's just here's this function. Let's find this absolute value. Average value. Sometimes it's just integrals.
We're gonna get a second derivative where they ask you to go all the way back.
Not with average value.
So
It's gonna be a number. They have so
Okay.
many evil problems.
Fundamental theorem on this. Because it's got 0 to 6. Yes. Yep. Antiderivative.
Someone genuinely wrote all those problems and they had to solve them. How many people work on a math book, do you think, Ms. Douglas? Like,
How many people what?
how many people work on a math book? Like a textbook?
Oh, tons.
Because it takes even someone who's good at math a while to do all those problems.
Yeah, there's mistakes in there.
Yeah.
I find them. I think the people who wrote the book, though, aren't the people who do the answers. If that makes any sense. Like they would do the examples in there, but not the answers in the.
Even like college board mistakes.
Oh, yeah.
If no one made mistakes, then the world would look a lot different, Mason. Our class would be like half the size.
Our class would be half the size. Are you implying that half of these people made a mistake signing up for this class?
No,
Oh.
he's talking about like mistakes. You know, half of us are mistakes.
that's what he's saying.
You know, you think
Oh my
about it,
goodness!
we have a lot of ancestors. Everybody's gonna have one ancestor that was a mistake, so none of us would be here.
Yikes, Mason! Nobody's a mistake.
Are we counting happy accidents as mistakes?
Happy
Or
accidents?
do you have to regret
I
it?
wasn't supposed to be this.
Like, do your parents have to regret it?
I wasn't
Or do happy accidents?
Yikes! Okay, anyway, moving on from all of you people's miserable philosophy of life.
So if it's a mistake and then they're happy with the mistake, then it's a happy accident.
Yeah. They were like, put them back in. Put them back in.
How about unintended? Unintended.
Happy on
As opposed to a mistake.
Well, I'm asking if it's different. Like, a happy accident is okay. That's what I'm saying. Like,
Yeah, I was an accident. I like it.
What's the answer?
46.
46. Okay, antiderivative of this is what?
X cubed plus 2x squared minus 2.
Okay, we're going to plug in a 6 and plug in a 0. What do you get when you plug in the 6?
276.
And when you plug in a 0, you get 0, and you're going to divide by 6, and you get 46. Okay, that's average value. I don't really have anything else to say about it. It's pretty easy. Let me check my book, and we'll see. That's all we got for today.
I wanted my sister to be a boy.
Yikes!
Oh, I see what it is.
My parents paid for my sister.
And she just naturally.
And I was just an accident.
Caleb, your parents is going to this room.
Oh my heavens, you poor people.
My parents have been done with kids for 10 years.
I think my parents just wanted. My mom just wanted to go.
Yeah.
My parents were having kids 15 years ago. It's all
Like,
old.
by the time they got to Judah, they were.
Careful.
That's June. You know the fairs like June
So I
and some
don't
stuff?
think I was.
They went through 4
Also-
years trying to go to Jackson, June,
My
Hudson,
sister's
Buck.
10 years older than me.
Okay. If you are Gold Star,
I don't know, I feel like in the end, being a
She's like,
is actually good. Like you're,
not if both of your parents wanted to go to college.
but I'm also saying like, you get to be around, most likely your grandparents are along, around.
Yeah, that's true.
That's true. Both sets of my grandparents.
There you go.
They also had tea parties, so.
You got 10 minutes. Work on this.
Growing up, and growing up, I didn't know myself with my grandparents. How old were they?